All right, let's talk about a word that, can sometimes make people a little nervous. The logarithm. It sounds super complex, right? But I promise you, the core idea is actually pretty simple. And its impact? Well, it's absolutely everywhere. By the end of this, you're going to see how this one single concept helps us calculate, scale the entire universe, and even, get this, understand our own minds.
So here's the game plan. We're going to start with the most basic question that logarithms answer. Then we'll see how they're just the flip side of something you already know, exponents. We'll discover why they were a legit superpower for centuries, look at how they tame enormous numbers, and finally, we'll uncover this hidden logarithmic code that's running through music, computers, and even our own psychology.
So, first things first. What is a logarithm? Let's just forget all the fancy math speak for a minute. At its heart, a logarithm just answers one simple, straightforward question.
That's it. That is the whole idea right there. How many times do you need to multiply a number by itself to hit a specific target? Let's just make this real with a quick example.
Okay, let's ask the question, how many 2's do we need to multiply together to get the number 8? Well, if we start with 1 2, that's just 2. Not there yet. Let's multiply it by another 2. That gets us to 4. Still not there. Let's multiply by just one more 2, and bingo, we get 8.
So the answer is 3. It took 3 2's all multiplied together to get to 8. And believe it or not, you've just solved a logarithm.
And this is just how we write it down formally. The logarithm is the answer, in our case, 3. The number we were multiplying over and over, the 2, we call that the base. So we'd say log base 2 of 8 equals 3. The logarithm is simply the count. It's the answer to how many.
Now, if this whole process of multiplying a number by itself is ringing a bell, it totally should be. See, logarithms are deeply connected to something you've definitely seen before, exponents. In fact, they're really just two sides of the very same coin.
Just look at this side by side. An exponent, like 2 to the power of 3, asks, hey, what do you get when you start with the base and the count? The answer is 8. A logarithm flips that completely. It starts with the base and the answer and asks for the count. See? They both use the exact same 3 numbers, 2, 3, and 8. They're just solving for a different piece of the puzzle.
So if you remember one thing, let it be this. When you see something like log base 2 of 8, all it's really asking is, what exponent do I need to put on a 2 to turn it into an 8? And the answer, the logarithm, is that exponent. It really is that simple.
Okay, that's cool. But why? Why did anyone even bother inventing this? Well, it turns out that for hundreds of years, logarithms weren't just a neat trick. They were nothing short of a superpower for anyone doing serious calculations. I want you to imagine you're an astronomer back in the 1600s. There are no calculators. You're trying to figure out planetary orbits, and that means multiplying these gigantic, multi-digit numbers together by hand. It was just excruciatingly slow, and a single tiny mistake could throw off months, even years of work. It was a massive bottleneck for all of science.
And then along comes the magic trick of logarithms. They have this incredible property where they can turn a really hard multiplication problem into a much, much easier addition problem. You just look up the logarithms of your two numbers in a table, add them together, and then find the number that matches that new logarithm. Division becomes subtraction. This was an absolute game changer.
And this brilliant idea, first published by a guy named John Napier in 1614, it took off like a rocket. Giant tables of logarithms were created, and pretty soon the slide rule was invented, a mechanical device based entirely on these principles. For over 300 years, that was the tool for engineers, right up until pocket calculators finally took over in the 1970s.
But the story doesn't end when calculators show up. Logarithms have another incredible superpower. They help us make sense of things that exist on ridiculously different scales.
Take earthquakes, for example. If you try to plot the raw energy they release on a normal chart, a magnitude 6 quake is about 1,000 times more powerful than a magnitude 4. On a graph, the 4.0 is like a tiny little pixel, and the 6.0 is a skyscraper. It's basically impossible to compare them visually.
And that is exactly where the logarithmic Richter scale comes in. Each whole number step, so going from a 4 to a 5 or a 5 to a 6, it isn't just one step up in energy. It represents a massive multiplication of energy. This whole system compresses this enormous range into a scale we can actually understand and work with.
You know, we see the exact same idea at work with the pH scale in chemistry. Neutral water has a pH of 7. Vinegar has a pH of about 3. Now that difference of 4 on the scale doesn't mean vinegar is 4 times more acidic. No way. It means it is 10 to the power of 4, or 10,000 times more acidic. Logarithms let us talk about these huge differences using small, simple numbers.
So yeah, logarithms are great for scientists, great for engineers, but you might be shocked to find out that they are also deeply embedded in the world all around us in some really unexpected places.
Just think about music. The way our ears perceive pitch is logarithmic. Going up an octave on a piano isn't adding a certain number of sound waves. It's a doubling of the frequency. Each note, each semitone, is a multiplicative step up from the last one. The entire structure of our musical scales is fundamentally based on logarithms. It's all about ratios our ears hear as being harmonious.
And in our digital world, oh man, logarithms are the secret to all that speed and efficiency. When you search for something in a huge database, a computer doesn't check every single item one by one. It uses something called a binary search, which takes about log base 2 of n steps. So what does that mean? It means searching a list of 1 million items doesn't take 1 million steps. It takes about 20. That's why our technology feels so incredibly fast.
And here's the wildest part. It seems like our brains are actually wired to think logarithmically. Our perception of loudness or brightness isn't linear. A light that's 10 times more intense doesn't look 10 times brighter to us. There are actual laws in psychology that show the time it takes us to make a choice, or even the time it takes to physically point at a target, it all follows a logarithmic curve.
So from a simple question about multiplication all the way to a fundamental principle governing music, our computers, and even our own perception, the logarithm is this incredibly powerful tool for making sense of our world. It reminds us that sometimes the most important patterns out there aren't about simple addition, they're about multiplicative scale. So the next time you hear a chord or search for a file, it kind of makes you wonder, what else in our world is secretly logarithmic?